Good evening, everyone, and welcome to the Technorama Tuesdays 2021 webinar series. My name is Hannah Murray, and it's a pleasure to be with you in audio and pixel form this evening. I am the Student Services and Compliance Officer here at the Community Media Training Organisation. I'm also the Board Secretary of Technorama, and I'm here to help assist in asking your questions and any technical issues you have during the night. So thank you all very much for being here. And before we start the session, I would like to acknowledge the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respects to their elders past, present and emerging, and extend that respect to all Aboriginal and Torres Strait Islanders people today. We acknowledge that sovereignty was never ceded. To introduce our topic for the evening and our wonderful presenters, we have the incredible Josh Pearson, who is our Vice President of Technorama, to tell us more. Hi, Josh, how are you doing?
Wonderful, Hannah. Thank you so much. And I'm not sure about incredible, but I'll take anything I can get. Hello all, welcome. Quite a popular session tonight with quite a few people jumping on and attendees still coming in. I'm going to jump straight into it. As we've got three people tonight that are going to be speaking about advanced Raspberry Pi. It's quite a popular topic that people have spoken to us about. Ignore the mess of my office in here behind it. Right off the bat, look, we're going to get started. We're going to take you straight to John Maisels, who has pre-recorded his session with us today. He's currently he's on the call, but unable to present from where he is, so we have a pre-recorded session from John, which I'll share now. John talks to us about the Pi 400 and the Raspberry Pi. One of the gadgets that you can come with the Raspberry Pi, it's a Pi built into a keyboard, comes with a whole bunch of stuff. John will talk more about it. I'll hand you over to him now.
G'day. So, having talked a little bit about what's in the Pi family, this is an opportunity for you to see some of the hardware. And I have a desk here that is just out of shot and is absolutely covered with things. So let's talk about the Raspberry Pi family. The smallest one is the Pi Zero. Now, this one's in a little case, but there it is. That is the smallest thing. That's the full Raspberry Pi. Everything that will run on the big ones will run on this, just a lot slower. The biggest difference about the small ones is that they don't have as much I/O. So this one comes with two micro USBs, one for power and one for connecting other things to. So the first thing you do is you connect a USB hub to that, and I'll talk about that in a second. And there is a video connection, which in this case is a mini HDMI connector. And then on the back, there's a socket that takes an SD card. So there you go. That is the entire thing that will boot up and run noobs, just the same as the big one. After they produced this one, which doesn't have any inbuilt I/O other than the USB connector, they created this one. Now, you could be forgiven for thinking this is almost identical, and if I can get them orientated the same, there they are. They look pretty much the same. The difference is that this one has a little bit of extra stuff just in here, which is Wi-Fi. So this one, the Pi Zero W, has inbuilt Wi-Fi and can connect directly. This one I got going with very little trouble, just a tiny bit of Linux hacking, and I'm not even a Linux person. So it took very little to actually get in there, add the definition for an external Wi-Fi card, just a USB dongle, and another USB dongle I happen to have, which was an Ethernet dongle. So I connected them both up. So this one's actually enabled, once the devices are plugged in, to connect physically to the LAN here. Coming up a bit, then you've got the bigger Pis, the Pi, the 2, the 3. They're all the same form factor. They all look like this, again in a case. They're characterized by having some USBs on the end and having an Ethernet connector there. On the other side, they have, in this case, the 3, one HDMI connector, a power input connector, and this has some audio on board. And then various of the earlier ones had various amounts of video connection, composite video, whatever. They all have a camera adapter, although I have yet to play with the camera. And all the Pis, and you can just see it there in the shot, they all have this 40-way connector, and that's how you access the Pi directly to allow the Pi to control stuff outside this box. And more about that in a second. The 4B, the latest version, looks almost identical. If you were looking at it, the big difference is you'd see that 2 of the USB connectors are blue, so they're USB 3. Other than that, you know, pretty much the same. And you can catapult any one of these out, put another one in, and they will run exactly the same. And the only difference is speed. Now, up until recently, the Pi 4 in this form factor was the top of the range. I got very excited in December when we did the Technorama Tuesday, and I heard about the Pi 400. So of course, I'm the maze. I had to go and get one. And here it is. The difference with the Pi 400 is that it is built into a case, and the case is a keyboard. So when you look at the top of it, you have, you know, it's not very big. You have the keyboard, and the back has all the connectors. It has one fewer USB connector, which is not in any way a shortfall. It has a power connector, which is just there. It has 2 HDMI connectors, in this case using HDMI micro connectors. It has a slot for the SD card, and over here behind a peel off piece is the 40-pin connector. So there you go. You take this out of the box, you plonk it down, you connect things to it, and it comes up pretty much straight away. Now, I bought this as a kit, and that's probably a good thing to do. So I'll just show you what came with the kit. It came with a Pi mouse. It came with, and you would need this, it came with the micro to HDMI connector, and it came with the power supply. Power supply is particularly important. This Pi pulls about 3 amps at 5 volts. So 15 watts, not very much. But I have found that running it on a 2 amp supply, for example, leads to tears. It runs, and then suddenly it will fall over. If it fell over while you were in the middle of coding something up, that would be a little bit disappointing. So Terry will tell you, and I will tell you, and Evan will tell you, don't scrimp on the power supply. That will lead to tears. Also in the box, when you buy the kit, you get the Pi branded adapter, but the the SD card that comes with this is in fact already in the device. And there's one other thing you get in the box, and it's the manual. So you can open this up, you can RTFM, and then go and actually do things. I'll comment about that. I made a mistake. I did not read the manual before I started. That also led to tears, although for not the reason that you might expect. So there you go. Come back to this in a second. What you need with any of these Pis, because they have no peripherals, is some things to get you started. So unless you have the 400, you will need a keyboard. You will need a mouse. You will need a screen. So that could be a TV set, it could be anything. I've run on screens ranging from really stupidly tiny to quite big, you know, the TV. But something that has reasonable resolution. The software will work out what the resolution of the screen is and adapt accordingly. You don't have to think too much. If you are running with a device that doesn't have lots of USB connectors on it, viz the Zero, you'll need an on-the-go adapter. So that's one of these things. They're pretty standard with mobile phones, particularly Androids. They have the micro USB connector and, no, hang on, whoop. They all look the same. They all look the same. That's it. Micro USB, and on the other side is a full-size USB. And from that, you can build out your ports, because you can take any old USB hub, plug that into here the right way, and then you have the ability to build that out. I would make a point that if you're using the Pi 0, it doesn't have a lot of power capability, and so I use a powered hub which has volts input somewhere. There it is. So this one takes volts in. It has 7 connectors. This is only a USB 2 hub. USB 3 if you need the speed, particularly if you are connecting an external hard drive and running off that, or an SSD to the Pi. USB 3 as far as you can. But it's really just a matter of speed, not whether or not it will work. You need some sort of operating system. The operating system of choice is Raspberry Pi OS. That is freely downloadable. You just go to Raspberry Pi and search on Noobs, N-O-O-B-S, which is the operating system for people who are just getting started. It has a long acronym that I won't bore you with. You can find this. Right now, the image is about 2.5 gigs, so it takes 5 minutes to download. I tested that on my 50 megabit NBN connection. It actually just came down rock solid at about 58 megabits when I did it in the morning, and bang. So they've obviously got good CDNs and good loadability for the software. That is excellent. You download that to your machine of choice and then use that machine to load up the SD card. All the instructions are there. It is fabulously well documented. Something that is optional but probably highly desirable is to come up with some sort of sound. The Pi family does not really have sound as standard. However, it supports sound as standard pretty easily. So I used this thing here, which is USB to arbitrary input and output connector. Pretty much any one of these dongles that, if it'll work in Windows, it'll work on this thing. Although we have in testing found that some of these sometimes don't work the way you expect. And I've certainly found that it's difficult to make a browser session come out of the audio hole that I want. But if you're using some of the software that's provided, for instance, VNC, the video player, you can tell it exactly which hole the audio should go in and out of. And that would be true of most tools that can identify the audio connections. Now, I also bought some extra bits and pieces when I got this because I figured I would need it. One is this extension card. So this extends out so you can get to all the pins. Typically, any of the extension cards that you get will label all the pins, makes it much easier for experimenting. That just plugs into the back of this, and it comes with some nice little feet so that when you sit it down, it's supported. And that's so that on these pins, you can attach what is called a hat. So the hat is the add-on board, stackable add-on boards possibly. Warning, there is nothing in common between a Raspberry Pi hat and a shield as used for Arduino. Not only do they have completely different pinout, but they also run on completely different voltages. It is possible to use one in the other environment, but it requires special care. There be dragons way beyond what we're doing here. Before I go any further, just where do you get some of this stuff? Okay, I bought this one from Core Electronics, who are in Newcastle. And it was, in fact, the cheapest place to get it. It was cheaper than getting it on eBay. But Core Electronics is set up by people who are into the maker-hacker space. They have a maker-hacker ethos. They want to promote the environment, as do we, where you are creating things and building things and fixing things, and they price accordingly. They're great to deal with, and you can call them up and ask them for advice. I did. We talked through this before I built my shopping list. They also have a lot of project experience, and they have a lot of resources available from their website. So that's Core Electronics. If you happen to be in a cap city and you have access to MSY, that is a place that is cheap as chips, especially for going and buying things like the SD cards. A very cheap supplier. They have a limited number of cables that apply. They don't have any other Raspberry Pi bits. My favorite go-to place for some of the extension pieces is Wagner Electronics, or WES, in Sydney. WES will ship all over the country, and as Evan has told me, you can order with Wes and it'll be on your desk the next morning. He typically in Cairns will order something one day and it'll be with him the next day from Sydney. So fabulous. Wes, for example, had these micro HDMI to HDMI connectors. So to build this out without having special leads, although that's a special lead, and that was about $9. I bought 2 of those. It's been an absolute lifesaver. Especially, by the way, if the screen you're plugging into doesn't have a full-size HDMI connector. And indeed, I should have shown you this. I have a portable screen. So this whole thing becomes part of a portable kit. This is a portable screen. It's self-contained. Sockets on the side for getting video in and out, and it's a touch screen, and it will run on its internal batteries or external batteries. And I frequently power the whole thing off. This is great. This is an Aldi battery and an adapter that I got with an Aldi kit, which has USBs. This unfortunately is only 2 amp output, and that's not enough. So my next step is going to be building out from here with a couple of spade lugs. And I'll go and get a 3 amp voltage converter, so like 20 volts down to 5 volts. Probably I'll get that from Banggood or from AliExpress because it's a way to do it. So, okay, screen, but that screen has a mini HDMI, and I defy anybody to get a micro to mini HDMI lead. But the adapters, every adapter I've tried has worked just perfectly. Also, I noticed Altronics have just brought out their latest catalog. Altronics is supplying a large amount of Raspberry Pi. So they're available, particularly if you're in Western Australia. If you're in Perth, you're really well sorted. In other cap cities, a little less so, but they will ship anywhere. And finally, Element 14. So Farnell/Element 14 are the official importers of the product. So that's, if you really want the go-to and you're prepared to pay, they will get anything to anywhere. Just so you know, this complete kit that I got from Core Electronics, so by the time I got this, the kit of all those parts was $152, which I think is just an absolute steal for a complete workstation. Just add screen and you are off and running. You don't need any more. But I also got the hat extension, so that was another $10. I got a ribbon lead to extend off the hat extension, so that was another $5. I thought that was pretty good. It's a 40 to 40 pin lead, but don't be confused. IDE leads will not work because they probably have 1 pin missing or 1 pin blocked. What else did I get? Oh, I got the case because I thought I'm going to be putting this in my backpack. So this case to protect the 400, and that was another $10. So the whole thing cost me under $200 from Core, and I had it in a day and a half, which I thought was pretty spectacular, particularly in these times. There are a couple of things that are special about the Pi 400. It's got the very latest silicon, so it's got what they call 3G silicon, so it is ahead of the Pi 4, the standard form factor, and it's about 28% faster. So it actually runs more quickly, and even better, this has no heat problem. So you've probably heard that the Pi 4, if it's not run with a heatsink and it's run with a really hard load, it generates a lot of heat that you've got to get rid of, or it will shut itself down to protect itself. This does not have that problem. So there we go. I did try a whole heap of sound connections. I tried this one, which did work, although not on everything, and I think there's a bit of fiddling to go there. I tested with a Focusrite 18i20, so that's a pretty heavy sound interface. Interestingly, when I plugged that in, not only did Raspberry Pi OS recognize it, but when I went in and said, oh, tell me about the audio connections, it knew about all of the connections in and out. So I don't know what software support they actually have for that. It is, what we will say, a little bit hard to fathom, and I think some experimenting is worthwhile. And I did manage to break it while I was testing, and I fixed it by power cycling. That was the easy way out. Once I'd done that, I got sound back. I have no idea why sound went away, but power up and it worked. Terry has tested Behringer external devices. Something we do know about the Pi platform is it will typically support full duplex audio, so you can be feeding something in and getting something out really well. Most of the USB stuff we have tried just works. We've found a couple of quirks involving only one channel. The drivers are possibly not as easy to fathom as, say, Windows drivers or Mac drivers, but they do work. Now, just before I go, I found some gotchas, and there's stuff that you do need to know when you're working on this. When you're powering this thing up, it's not easy to understand which socket to use, but it is, in fact, you plug the screen into the one that is closer to the connector and you'll be okay. If you get that wrong, you just pull the plug out, move the video, plug it back in, let it come up again. I had a particular problem that is peculiar to here because at home we have a hidden SSID. There is no way to tell the startup process that you are on Wi-Fi with a hidden SSID and to force the SSID. If it can't actually see the SSID, it's not going to work. My recommendation is if you're bringing a Pi up, and this would be any of them that has the Ethernet connector, bring it up on that, hardwire it, it's just easier. Might not be any faster, it'll just be easier. So use the cable. Definitely read the manual. Just read the manual. Just take 5 minutes, read the manual about startup. If you blow the startup apart, you can come back and do everything that is in the startup later, or you can reload noobs and start again. But the automated startup, and it leads you through stuff, is really very cute, and you're better off being in position to have that work rather than not. You can always set everything up manually. I found when I was using two screens on the 400 that the screens don't butt together. There's this curious area in the middle that isn't on either screen. Don't know why. That's subject of further investigation. This is the out-of-box experience. I absolutely have not had any problems with cooling, but then I haven't really threatened this with any particularly hard activity. Generally, I just plugged it in and it's worked. And pretty much everything I've tried, every website I've gone to, things that didn't work on an old Apple iPad work just fine on the Raspberry Pi. So in closing, would I say this is a device to consider for use in a station as a workstation instead of a Windows or Mac workstation? Yeah, absolutely. You can do a lot of stuff on one of these really safely because you're unlikely to be subject to viruses or other nasties with one of these. And, you know, if you are, you can blow it away. It's really easy. It's a great platform.
Push the right button, it helps. Thank you to John for that. Next up, we have Terry O'Connor. So an early pioneer in the community broadcast movement. Terry's starting to share his screen now. Terry has built, used some clever software that can be really easily downloaded onto an SD card and installed on the Pi called OpenOB. Let me write my notes correctly.
That's one of many.
One of many, which is the and I think InStreamer, Xstreamer. There's a few others that you can do to send or receive audio across the network. And then following from Terry, we'll have Evan going through some projects that he's built on the Pi, which are pretty cool to look at. Just a friendly reminder, everyone, to jump on the Q&A feature, top of your screen, click Q&A. You can ask questions whilst we go along, and we'll try and answer them if we can answer them as we go in. So just jump on, don't put them in chat because they sometimes get missed if there's multiple chats. Just jump onto Q&A and type your question and we'll jump it in. I'll hand over to yourself now, Terry.
Thanks, Josh. Look, as far as audio devices are concerned for the Raspberry Pi, there's quite a number to choose from. There is some audio capability in the Raspberry Pi, what we call the Raspberry Pi Model B. It does have some onboard audio through a 3.5 millimeter connector on the side. But if you want some higher performance, then the devices to use are what we normally record. You should be considering the USB devices, as John has mentioned, or or a digital to audio converter as an add-on hat, and there are also digital to audio, audio to digital converters available as well. So we're going to take a look at some of them. Plenty to choose from very cheap to moderately priced. Raspberry Pi OS will detect the USB devices. They use the advanced Linux systems architecture to detect the audio device, and the success that I've had using Audacity has been pretty good. When you use one of these the Behringer UCA 222 devices, they don't exactly behave the same way as what they would if they were in a Windows machine or an Apple Mac, but we'll come to that in a moment. Some USB devices, as I mentioned, there's a couple of them there. The Euphoria devices from Behringer, as well as the UCA 222 and the UCA 202. They're both quite inexpensive. The Euphoria devices, I think they're around about $150 for an entry-level device. You can get up to four audio outputs and 2 audio inputs working out of that quite comfortably. If you happen to have a Behringer mixer that has, or any mixer for that matter, that's got an inbuilt USB adapter, you can plug them directly into the Raspberry Pi and you can record and replay directly to and from that device, no problem at all. Some of the recommendations, as I said, there's plenty to choose from. Some stations may already have some of these devices, so there's really no hard and fast rule that you need to be following, and Behringer is not the only supplier of USB devices, so it's a matter of have a look and see what you've got. If you have a USB audio interface, give it a crack, and you'll probably find that it will work quite nicely. The DAC, or the digital to audio converters, these are a must-have if you're looking for high quality audio. Now, the B models prior to the Raspberry Pi 4, they all share the USB hub that's built into the Pi for things like Ethernet as well as external USB connections. So using a hat or a DAC gets away from any congestion that you might find on the USB bus. There is an interface via the GPIO pins called I2C, and that is designed for high-speed data transfer between devices. So it's particularly good for using with these devices. So, as John already mentioned, we call the add-on boards a hat, and prices start at around $20 to $25, and they go up from there. The Pi-Fi Berry Plus version 2.0, that's a Chinese equivalent of the Hi-Fi Berry high performance card, and that seems to work pretty well. So that, I think they're about $25 when you source them. Some of the more commonly available DACs, the Hi-Fi Berry DAC is the green card up top. These are all replay only devices. The Pi-Fi Berry is the blue, and the IQ Audio DAC is the card at the bottom of the screen. Now, John did mention to me earlier this afternoon that the Raspberry Pi Foundation, which oversees the development of Raspberry Pi, has recently acquired, or there's a rumor going around that they've acquired IQ Audio. So watch this space. There's going to be some very interesting developments coming out of that space. Obviously, the Raspberry Pi Foundation sees audio applications of the Pi to be very important to their future, and more on this to come. Hi-Fi Berry also have a DAC that has a balanced XLR output. Hi-Fi Berry devices are imported from Sweden, from Switzerland, and as you would imagine, the price on these devices for the card, it's $89, and for the metal case, which is highly recommended, is around $40 for that as well. So if you're looking at wanting a replay device that's got balanced outputs, this would certainly be one of the considerations that you would like to have. Even DACs for the Pi-Fi, for the Pi Zero, sorry. There's plenty of these devices kicking around. This is the Pi-Fi Berry DAC and the Pi-Fi Berry case for the Pi Zero. So if you're looking at a device simply to use as a replay only, to replay, say, BBC World Service, or monitor your audio stream from your hosted streaming server, this would be a pretty good starting point. Now, the analog to digital converter side, we don't seem to have quite the range that we have for the digital to audio converter side. Hi-Fi Berry in Switzerland does have a card that will support recording. It's about $99 or thereabouts. These do support 192 kilobits per second, 24-bit encoding, and the output quality of these devices is pretty good. But as I say, the only way you'll get audio in and out of this particular card is that if you look here on one of these, on the picture at the bottom of the screen, it says item 3. You have to arrange your own I/O connector for connecting external audio into this card. Now, this is an Australian development and from Flatmax Studios, and I've been particularly impressed with these guys. This is a project that has been crowd-funded, and the thing that really impressed me about these cards was, firstly, the price, but secondly, they have a manual volume control, which you can adjust the input level to the card, which is can be quite desirable. This is the Zero Sound card that is available from Flatmax Studios, and they also have what they call a stereo sound card, which is designed to sit on top of the Model B Raspberry Pis. So this you can use on anything from a Raspberry Pi 2 up to the Raspberry Pi 4s, and with the adapter module that John showed you earlier, you could even sit one of these things on the back end of a Pi 400 as well. But the idea is you'd need to put them in, arrange some sort of box to protect them. In recent times, there's now been an Audio Injector Pro sound card, which has balanced in and balanced out on the card itself. It has, once again, 192K sample rate, 24-bit, and it uses a CS4272 codec, and these cards do show a lot of promise. Down the bottom left-hand side of the screen, that is the Flatmax Pro card that you can just sit on top, plug directly into the GPIO header, and the right beside it is the XLR interface card. Now, one of the things that Flatmax Studio doesn't have is any cases to accommodate this. So this is another project that we're looking at trying to do something with 3D printing. So what are the projects that you can use these devices for? An audio workstation is basically the base install of the Raspberry Pi OS, and all you need to add to that is Audacity. And there you've got a full digital audio workstation. You've also got LibreOffice for doing your normal office productivity activity. You can also build an audio, an MP3 stream encoder loaded with Dark Ice and the IceCast streaming server, if you wish, and then you can even host that on your own if you're fortunate enough to have 100/40 NBN service, which is what I've got here at home from Telstra. That I have a demo service running off that at the moment. You can also use it as a stream player, and you can also use the OpenOB STL system. You do need the stereo sound card or the Pi-Fi Berry card at the receive end. Now, the thing about OpenOB is, in the testing that we've been doing leading up to these presentations, we have found that with the USB interfaces, for some reason, the stereo operation is not supported. It's not an issue of what I've been able to work out. It's not an issue of the USB drivers or the USB interface into the Raspberry Pi. It's more a question of some of the GStreamer code that is used, because the tool that sits underneath OpenOB is a package or a series of packages called GStreamer. So there is something not quite right in amongst all of that. I've had Raspberry Pi Model B2s running all of these instances, and they all work fine. Once you use any of the hats to connect your audio into the Pi and get your audio out of the Pi, there seems to be no issue with running stereo. So, and there's certainly no reason why the 3B Plus and the Pi Force wouldn't give you the similar service. So really, what should be your starting point? If you're new to the Raspberry Pi and Linux in particular, take some small steps. The Raspberry Pi 400 is a remarkable and a very good starting point if what you're looking for is a workstation type environment. Now, if you have USB devices, you can certainly augment them, and they and becomes a very flexible audio editing workstation. Any projects that you're going to get involved in, you will need to be thinking about budget, the type of device, and just how much time and effort you're going to be putting into it. So this comes down to what we've done at Technorama. We've put together a number of Raspberry Pi images that are already pre-built. So all that you need to do, we've more or less taken away all the hard yards. So all the dramas of getting packages loaded into the Linux environment, we've done all of that. We've tested it. We know that it works. We've even put together some of the startup scripts that are needed to get these applications running. So we've got a selection of them. There's the workstation and the digital audio workstation, which are pretty straightforward. The audio streaming server and the stream encoder, that will be based around the FlatMax Studio cards, and there's a little bit more work that still needs to be done. And yes, we are looking at organising some Technorama Pi Jams. And yes, that is what they call them in the UK, where people get together and learn from their collective experiences, and people show off the things that they've done. So that's yet to come, and also a web-based support a forum to assist stations and technologists and enthusiasts at your station to master this technology and exploit the absolute daylights out of it. Back to you, Josh.
Thank you so much for that, Terry. I guess there's something we're always going to learn is there's lots you can do with these Raspberry Pis. We have had a couple of questions, and I will throw to Hannah to lead a quick question time before we jump on to Evan.
Great. Okay, a couple of questions. We've got one from Peter Van Schaik. Will the Raspberry Pi run JavaScripts natively?
Good question.
Terry.
I've not come across it. But within a web environment, you'd expect it to.
The answer is yes, you can. How to do it is a convoluted, weird process, but yes, you can.
Okay.
Great. Next question is from Rod Pettit. Audio hats. What about audio streaming to a remote site with transmitter and Pi? Transmitters generally have MPX, not L&R XLR.
Yes. My experience has been to do the MPX encoding at the transmitter if possible.
So you're saying, Terry, we can use the Raspberry Pis to create a nice little streaming link, have it all up there ready to go, and then convert it to MPX once we actually get it to the transmitter site, which can be done. Anyone else wants to?
Rod, I hope that answers your question. If anyone else has a question they'd like to ask in audio form rather than writing in the Q&A, there's a raise hand function that you can use. If you'd like to click it, I can pop your voice on and you can ask your question by speaking rather than typing. So I'll give you a minute to do that if you need to. Rod, I'm going to allow you to speak. You'll have to unmute your mic though.
Hear me?
Yes, we can hear you, Rod.
Great, thanks guys, and Hannah. So in fact, regarding, I guess, further on that question, so what we're looking at doing is sending audio streams to our 3 remote transmission sites, potentially using the Raspberry Pi to accept that stream at each of those sites. So, all right, so now I get, for example, an XLR output, but my transmitter has an MPX input. So now I've got to convert XLR to MPX. In other words, I need another box to do that, not a hat that's capable of it.
Yeah. How are you getting that to getting the program to the transmitters at the moment, Rod?
At the moment, I'm using the standard analog method, but I'm looking at, we actually have IP links to our transmitters now, and I'm looking at what methods I can use to audio stream digitally, really as a backup to our current analog path.
I'm not aware. Converting the MPX stream to digital and then trying to transport that over the internet, that's going to take up a fair slice of bandwidth.
Yeah, I'm just doing some quick research on it for you, Rod. There doesn't seem to be a straightforward answer on that. There are several attempts of generating FMMPX on a Raspberry Pi that you can stream audio in and then convert it on the Pi and then output MPX directly. I'm just having a quick look at a couple of sites. I'll send you some links that I've found that might help you with the research, and we'll also put them up at the end of this on our Technorama
All right, great.
Website. It's a good little thing. I think there's a few people who have had it, and one of the comments in one of the articles I read that if I had the chance to do it again, I wouldn't do it.
Okay, thanks, guys.
But not to mention that you shouldn't be doing it.
Thank you.
Any more questions, Hannah?
It doesn't appear so, so it's probably time to introduce our second speaker.
Excellent. So our second speaker tonight, Evan, will hopefully start sharing. Hello, Evan. Evan joins us from far north Queensland. Has been building some very cool, I think a very cool Raspberry Pi projects that involve audio selection, studio selection from remote and satellite studios. Had a bit of a look at this yesterday on a test Zoom, and it looked pretty impressive. There's some really cool projects that Evan's running out there, and something he's built, and happy to share with you today. Evan, over to you.
Yeah, thanks, Josh. Hi, everyone. Yeah, well, from what the spiel that Terry's been giving about the Raspberry Pis, and especially OpenAB and streaming, pretty well covered all the technicalities of that. So what I would like to show you anyway tonight is 3 projects that came about just using the Raspberry Pi. It was an approach to the cheapest solution to streaming to stations who don't have a lot of money to splash around. We know that. And in fact, the Raspberry Pi was pretty good. It proved itself more than adequate for the job at hand. So what I've got here, I'll show you a simple one and a little more complex than a rather one that just got out of hand, I think, anyway. But,
Evan, you'll need to share your screen.
oh, I did not share the screen. I thought I did. Yes, I did. There you go. All right. Share screen up.
Yep, all good.
They're all good? Okay. So this presentation here is just 3 projects that I put together, and they can be quite easily built by anyone with a limited amount of knowledge of the Raspberry Pi. Well, it's a sharp learning curve and you can get your head right around it. So 3 projects. First of all, was an OV streaming project. The second one came from that because there was a couple of issues that came up, or there was a project and we were trying to figure out how to have 14 remote studios could we get programmed back to the hub studio. And I'm talking about in the Torres Strait and with the RIBs as remote Indigenous broadcast studios. There's a lot of those around the country. And also the COVID kicked in, and of course that flagged up, well, hang on. People have wanted to broadcast from home. So here we are. Here's a remote studio network that could hook in all your remote studios, and everyone can quite happily broadcast from home with this network. And the third one was a little offshoot from that. I was just playing around with it, and the online radio streamer. We all have favourite programs that in the studio we like to go cut across to a news program, or we like to cut across to maybe the ABC, do a football match or whatever, you know. And this little player was a simple solution to that. And you can sit on your desktop. You can you can use bookmarks and toolbars and things like that. But this was just a little neat solution to that just sat there and you double click, open it up, and the player's ready to go. So let's have a look first at the OV stream. So the project required, it was a media festival up in the islands, and it was only for 4-day OB, and of course they wanted to stream from that studio back to the main studio. But when they asked me to do that, it came up with a couple of issues, because the particular studio they wanted to use was located within school premises. And of course, as we know, government departments, they don't like you piggybacking onto their networks or using their telephone system. So I had to skirt around that, and I figured, okay, it's OpenAB, as Terry described there. They're pretty flexible. They pretty well operate on most conditions, and they're fairly stable. So I've set up a test rig here on my bench at a 3G modem and a Raspberry Pi into that. And then I just streamed out using OpenAB and back to my desk again, and it ran all day and didn't miss a beat. So the mobile signal was pretty good in that location. And of course, I didn't want to spend a lot of money on it. So Pi to the rescue. So that's what I did. I installed a Pi program streamer server at the remote studio. As I say, the 4G mobile router at the stream end, and used prepaid. That was fine. Put the Raspberry program stream receiver at the main studio. again with OpenOB. The top had audio card. I think I used a UCA 222, I think, for that one, but both of them are quite good anyway. Well, it was suitable for this application. And the OpenOB streaming software was installed on both Raspberries. So this is what it looked like. So on the left-hand side there, we had the OpenOB, of course, very basic. And I've drawn this up as a very basic system. You can do that. You could use this at home for your home studio. The Behringer mixer, yeah, around about $100 or so, selling down DJ stores in Melbourne. The Raspberry Pi with OpenOB loaded, 4G router from Officeworks, and a nice little antenna there from Jcar. So all off-the-shelf stuff, quite easy to build. And I think I put that around about $240 somewhere. Well, might have been more of that. Yeah, closer to 500. Sorry, the router was a little expensive. That was one of the most expensive items, as a matter of fact. So that stream would just head off and over to the studio, again through the studio's router, into the Pi there, running OpenOB, into the USB, and then straight down onto one of the channels on the mixer. And that was it. It was a very simple solution. Did the job, worked like a charm, no complaints. So an extension of that then came along, as I said, COVID came along, and I started, okay, they got all these studios we want to network. I could just reapply that and just multiply that same principle and build up a whole network. These studios are on the islands. They needed a reliable internet and phone service for these studios, remote studios. All the studios not able to reliably send a program stream to the hub studio, which is in Thursday Island. Some of the studios lost the ADSL phones, and their phone lines, because what would generally happen out there, a studio would work for a while, and then, it probably may not operate for a while, and then another person come back and operate, and so they have their ups and downs. That was normal. And of course, the council out there said, "Oh, no one's using that," so they'd swipe their phone lines, or they'd end up going somewhere else. So anyway, trying to get a new replacement ADSL service, not easy these days. Everyone knows that. Telstra and the rest of them don't want to know about it. So mobile reception was pretty patchy up there, so I couldn't use that principle again. And of course, limited budgets. So the project was to bring all these 14 studios in. Satellite broadband service I saw as the best option for each of those studios. Also came with that was a VoIP telephone handset for each remote studio, which is great. And that streaming service provide a reliable program streaming from the remote studio to the hub. Also, one of the key things here was to make it plug and play. Don't want to get too complex with this operation. It was very simple. You plug the box in one end, you plug your receiver in the other end, you turn them on, they talk, they stream. That's it. Don't have to do any more. So the first stage of this was not to get all the 14 up, but we looked at a group of them first, of 4. And I wanted to get the internet and the phone access up first, then install the streaming server at each of the remote studios. And then the hub end had to provide some sort of means of selecting those studios program coming back to the hub. That's typical of one of the studios out there. I've built 14 of those studios. They're basic, they're simple, but they're quite practical and they're very versatile too. As you can see, all using mostly ELAN equipment. And the computer on the right here that was running Simian automation, ELAN desk, CD players, switching box there. You can turn the studio to where, or you could put the satellite receiver to where for the network. That was it. Down here, program limiter, monitor amplifier, the studio, distribution amplifier, and the studio computer was down the bottom box. That was it. And so this is the network I put together in a block form. We talked about the streaming server at the remote studios there. Through a router, which is, as I said, was the satellite network. NBN, back to the studio's router, into the receiver box. So I built a box here with 4 Raspberry Pis in it. That was the first initial 4 studios. Audio out goes into another rack box, which is the switcher box. Audio out, main program, and the Q output into the studio. Inside the studio was a little touchscreen, a Raspberry Pi touchscreen, which could select each of those relays to bring in each of these, any one of these 4 Raspberry Pi receivers. So on the remote studio, that's what I built. Box from JCar, pretty simple. On-off button on the front, turn it on, it starts streaming. That's all you got to do. Inside it says the Behringer UCA 222 USB interface. You could use a top hat with this if you wanted to. But I had a few of those around, so I decided to go that way. The Raspberry Pi running OpenOB. And the push on, push off button, as you can see, there's some cables going down the back and they just plug into the terminals on the Raspberry Pi. So there's that capability is already built into the Pi. You can actually turn it on and off with a button. Fairly simple. In the back here is the LAN connection going to the router in the studio. And there's the USB audio cable coming into the Raspberry Pi. So that was the studio then. That was it. Pretty simple. Receiver end of the hub, there you can see it. What I've done is just rack box again from JCar, nothing special there. 4 Raspberry Pi with top hats on them. LAN cables coming in to a switch, go out to the switcher. And the outputs of the all the Raspberry Pis you can see there coming into this unbalanced, it's all unbalanced at the moment, to the audio outputs. And those outputs would then go down into the switch box, another rack box underneath it. So that rack box had a Raspberry Pi, 1 Pi, which had a web server for the touchscreen, and the GPIO controller for the relay board. So there's the GPIO controllers down the side there, the pins, cables coming over, control pins for the relay boards. The relays, all they do is just switch audio. You can switch the program and queue for each channel, for each receiver. 1, 2, 3, 4 receivers. Audio output, basic mixer there, by the way. Audio output to program out, that goes to the studio, and to the queue out to the studio. Down into the touchscreen on the studio end. So the touchscreen had manufactured here locally in Cairns. That was just a bit of Perspex spent at the local Perspex shop. They did that for me. Very simple. As you can see, a Raspberry Pi touchscreen, the controller. The web page, I developed that just using simple HTML, PHP, and JavaScript, by the way. Answers that question, Josh. Yes, you can run JavaScript. That's what it looks like on the front of it. There are all the communities had that I wanted to start with. I just put 8 on here, but I can have as many pages as I like. And there's the live version of it. So what you're looking now is the actual version sitting up there on Thursday Island. I can actually log into it and turn it on and off myself remotely. So you're saying, wow, okay. That means I can sit here at home and control the radio station. How fantastic. So the buttons here, the queue relay, you can queue anything you like. Coming in, you might have this station running. There it is. I know it's not going to air because they've left the studio up there and it's on automation and everything's closed off. I made sure of that. And yeah, so you can have that running. And you can also then say, I want to queue this station, see if they're coming in next. And you can listen to them on the queue bus on your mixer. So there's a lot of flexibility I built into this. You can have 2 stations on at once if you want to, maybe 3. They can all talk to each other, all coming in, basically mix packs to that mixer box and coming out as one program into one fader on your desk. So I try to build as much flexibility as I could into it. But that's it. That's Simon coming off Thursday Island now, running live. So that's the touchscreen. And from the touchscreen, then we're back to the studio mixer. So to give you an idea of how all this pulls together in a block form diagram, I just created this little diagram here. So there we have the network I showed you on the left-hand side. This is the block form, how it all works. A little dummy up the top here is the touch screen, station A, station B. Station A is on the remote studio, A and B. The receivers back at the hub, studio, A and B. In here is the relay switching, pretty basic stuff and nothing really difficult about that. I kept it really simple and practical and easy to replace, easy to fix is pretty important when you're in remote areas. And on this side, of course, the two Q buttons, A and B, Q, come out to the Q relays there. Leaving all that, I put it into a distribution amplifier because all this up to that point, as you can see, it's all unbalanced. And that's all around those two rack boxes. So it was no big deal. It took a lot of precaution to make sure no noise got into it. But before it left that, I put it into a ELAN distribution amp. And that was the studio feasible program and also the Q. So having a look at this now. So if you were in the studio, Studio A over here, the remote studio wants to come online, you press that button and bingo. The switcher puts program in onto the Raspberry receiver, open AB streaming. Relay pulls it up, puts program through there, out it goes to the studio. Simple. Studio B, do the same thing. Just switch that off, switch Studio B in, bang. There's program immediately at the desk ready for you to fade up and fade up. So you have that on there, and also you might want to listen to see if Studio 2 is ready and got programmed. So you can actually do that by Studio A is on air, its program is going out to the main program. Studio B, you can have a listen to down the Q channel, and that Q channel goes to your desk. And you can bring that up on your phones or however you do your queuing in the studio. And you can listen, yep, okay, there, I can hear their program. So that's all good. And of course, when they're ready, you just flick them on and away they go. They're on air. The other thing here is the web server, which is feeding the touchscreen. And that's on that Raspberry Pi, which is sitting in the switcher box here. There it is on its own, sitting up in that corner. It also controls the ports which do the switching of these relays, these 4 relays. You can see here Raspberry Pi's got this way of naming their ports, GPIOs, general purpose interface IOs. Pin number 17, number 18 for Studio A and B. So if I was to click on there, I'll get the Raspberry Pi here up on the left-hand side. There's the map of all the pins for the Raspberry Pi. So when I click on this one here, you'll see GPIO 17 comes alive because that button turned that port on, which is GPIO 17 over here, which is pin number 11, which is pin number 11 over here on this strip. Turn that off, same thing again. GPIO 18 comes on, and that's GPIO 18, which is pin number 12, physical pin 12. Pretty straightforward sort of stuff. And the same over this side, 2 and 3. There they are over there, 2 and 3. On the remote studio, again, there's the streaming box. We saw that earlier, with the USB audio, the Raspberry Pi. At the studio end, I used the Raspberry Pis with the top hats, as Terry was pointing out there before. Pretty simple, Raspberry Pi underneath, couple of standoffs, and there's the top hat sitting on top. And there's the system. To get all that to work, this is my test bed, just to give you a demo of what it can actually do. There's the Raspberry Pi, which is doing the controlling for the web page and also the controlling for the relay board. Relay board, straight off the shelf, Q channel, program channel. That's how I developed the system. And I will show you a little demo here of how it works. Watch the relay lights turn on just here. Relay on, another relay, there, and music. I know there was a program on there because I fed it in onto the terminal. Just on the side, you can just see the cable coming in, and that's coming from the satellite receiver. So that's the concept there can be used for many things around the station. For turning on your automation, turning channel faders on and off. It's unlimited. It's up to your imagination what you can do with it. So, but that's the basic system that I got working. Yeah, so back to, that's the network. And one little offshoot from this is, of course, very simple one. Anyone can build this one. Again, it's the Raspberry Pi with the top hat, 2 audio outs into the desk, into the router. The touchscreen goes into the router, and you can select all your favorite radio stations. You might have news coming down on NERS, you might have ABC News Radio, you might have BBC Radio that you like to do. You know, pretty simple stuff. All you do is create a desktop icon, and you can put it on any computer, Mac, Windows, Raspberry Pi, whatever. And when you're ready to use it, you just double click on the icon, the desk opens up, click the button and it'll play. And can be configured to run on a mobile device. I tried it on my iPhone, worked all right. All you need is a Raspberry Pi, the top hat card, virtually that's it. A bit of programming for the web page. If you want the touchscreen, well, of course, additional Raspberry Pi for the touchscreen and also the 7-inch touchscreen itself. Back to that, let's have a look at that. Practical application, yes, there it is. So if I wanted to listen to the BBC Radio, which should be streaming online right at this moment somewhere, there's a bit of buffering going on here, but I noticed tonight. There it is. That's BBC Radio Live. What if I want to go to Sima Radio up on Thursday Island? I want to pull that in and have a listen to their program. And the buffering is a little bit. Come on, yes, there it is. So you can see you can program this yourself and put any radio stations on there you like that suit your radio station. Just reset it. That's a simple little project. Good starter project, as a matter of fact. So there we have it. That's my solution, couple of practical solutions to some broadcasting issues that I've managed to fix using Raspberry Pis. Back to you.
Great stuff, Evan. I've got a question here from Greer Kemp. It's, how are you handling redundancy for critical studio and transmitter or other important paths?
Or I don't particularly relate to any radio station. I should explain that I'm a freelance tech. As I tell people, have toolbox will travel. I don't I don't work for anybody, any radio station. So what they do, I give them advice, of course, but what they do is up to them.
Okay. Terry might have some insight, or Josh, if I can invite both back.
Could you repeat that question, please, Hannah?
Sure. How are you handling redundancy for critical studio and transmitter or other important paths?
That's a fairly broad question. I would imagine that if we look at it in the context of, say, the Raspberry Pi and the use of the Raspberry Pi, if you were using that as, say, OpenOB, if you're looking to try and build robustness and redundancy into a solution of the like of what Evan's built, you would certainly make sure you got backup copies of all of your software that you've got deployed in the Raspberry Pis. I know there has been some issues with the reliability of the SD cards that have been used in the Pi. If you wish to, you can actually load the operating system onto a solid state drive or onto a hard disk drive and have the Raspberry Pi boot from that source. So there are ways around some of these issues. So you can get some long-term reliability into anything that you're building on the Pi platform.
Great. Josh, do you have anything to?
Yeah, look, I think on that, I guess probably talking specifically about Evan's project, that if you were to lose a link from a studio,
Okay.
local audio players, local, backup audio generators, all that kind of stuff will I guess cover it, but then you need to work on the link. So whether or not, I don't know, Evan, whether you have backup links running anywhere or secondary stream paths or.
Yeah. Sorry, I might have missed the point of that question, actually. They might have been talking exactly about that at the studios on those remote areas, yes. What backup have I provided for that? None. Because you're at the mercy of limited resources out there getting out. You're on an island, and ADSL, they're not putting them in anymore. They're not interested. The only way you can do it is satellite. And that's it. Satellite goes down. Sorry, you're off air.
Sometimes sometimes the backup is there is no backups, and that is an acceptable answer.
Exactly.
Hmm.
Yeah.
Is anyone else? I know we're running a little bit over time, Hannah.
Yes.
We are right to ask anyone else any more questions?
There's no more questions in the. Oh no, sorry, Stephen Wilkinson. What is the quality of the remote studio streams?
The ones that it's running Opus, I'm around 96 kilobits a second, which is quite acceptable out there. You've got to keep in mind too, for this particular project, it's mono, because the radio station on Thursday Island, it's an AM radio station, so that's what I'm feeding, AM. So stereo wasn't a big issue, so I could just keep the bit rate down, and the quality is quite acceptable. So running around about that 96. Mono.
If you're looking to get stereo quality and go for the Doctor, you can still use the Opus codecs. In fact, the Opus codec has been adopted by the European Broadcasting Union as being the standard for contribution links for broadcasting in the EU. So there's some considerable weight being put behind the Opus codec. You can run speeds up to 320 kilobits per second. In fact, that's what I've been using with the testing I've done. And you really, I might be getting a bit old. I can't hear the difference between what I'm feeding in and what I'm getting out. I can hear a bit of latency, and that's about it.
Just on that point there too, to answer again to that question, I'm limited by the actual bandwidth that's available on that satellite, as we all know. You don't come cheap, and you don't get a lot, so you've got to run at bare minimum.
Yeah, which I think that leads into the next question Hannah is about to ask.
Right.
Yeah, Stephen has followed up with, what are the speeds of the internet NBN?
Yes, well, what day is it? Is it raining? Which way is the wind blowing? How much?
The whole issue of NBN is quite a complex one. The run-of-the-mill internet service that everyone buys, the cheap and cheerful stuff, is what's called traffic class 4, and that is basically best effort delivery. Depending on who your service provider is, they may or may not offer you or have available service options that allow you to buy a data priority pack that gives you a portion of, say, traffic class 2, which is reserved bandwidth in both directions. So if you wanted that type of quality of service, yes, depending on which service provider you're dealing with, those options are available. And
how much you wish to pay.
Well, I'll say this much. The carrier that I've worked with for most of my life, they're not that expensive, relatively speaking.
Too easy.
That is good.
I hope that answers your question, Stephen. Is there anyone else that would like to talk about any projects they have going on at their station or ask any questions of our panel tonight? Of course, you can use the raise hand function, also the Q&A function as well. I'll give you guys a few minutes to do that. And while that's happening and while we're waiting, if you don't mind, I'll share a screen to tell you what's coming up for future Technorama Tuesdays webinars. If everyone can see that.
Yep.
Great.
Planning ahead. Look at this, hey?
Yes, all that forward planning. Okay. It looks like we have answered everyone's questions, or no one has anything to ask.
I could raise one other thing. John, I don't know if I missed it, Terry, but using OpenOB, did you raise the issue about the hacking?
No, I didn't.
Okay, so on that one, I better raise that one point. This is something which I found out the hard way. Was once I got the two streams working, OpenOB, I was just humming along the bench here quite nicely for days and weeks on end, and was working nicely. And then suddenly it was all going haywire. It was going strange. It was slowing down. There was glitches in the audio, and I'm like, oh my god, what's going on here? When I got in and had a look, I got hacked, literally hacked, because Reddit server is one of the bases of OpenOB, how it operates. It uses GStreamer and also Reddit as its database for knowing the data, how to connect each end, the transmit and receive, all that sort of stuff. But everyone knows that. It's what is it, 6739 or something like that, I think it was. Mm-hmm. Yep. So that's quite common. Everybody knows out there. So, and it's also a vulnerability, and I found that out the hard way. So solution to that was to put it on a VPN, and I've been running it on VPN, and it's been cruising nicely. No problems ever since. And the VPN that I actually used is called Zero Tier 1. If you want to write that down, Zero Tier 1. It's a great system. It's free. You just get a Google account, log on. I want an account, so I just gave them a Google account, created one. You log in, free service. You can have 50 connections for nothing. It's fantastic, suited my job. And you virtually just put all your devices on. They all get a ID, so they can ID themselves on the network. And then the whole thing just talks to itself, this whole network, including my desktop computer right here. I'm part of that network, so I can get into that network. Just open the browser, log straight in, and do maintenance on any of those remote studios. Another gotcha.
There's always some. If no one other questions or that kind of stuff, the only other thing I'll quickly throw up is if you head to the technorama.org.au, obviously you'll see all the upcoming Technorama Tuesday information, but you will also see a splash page that we've just put up that will be called, I need to bring it up myself, basically Pi information. So all the info from tonight's session will be on the technorama.org.au website, hopefully by tomorrow. So there's a splash page there. Just bookmark it if you want tonight. I'll put it in the chat now, and you can jump onto the website and find out all the information from tonight, as well as links of where you can get things and all that other stuff.
Mm-hmm. Yeah, big thank you, by the way, to everybody for tonight. The wonderful Evan Wyatt, Terry O'Connor, and Josh Pearson, our Technorama anchor for the night. Thank you, everyone, for making the time to come and chat and learn about the practical implications of Raspberry Pi at your station. It's been a long day. As you can see on your screen, we have booked up right up until June for the upcoming webinars for the series. You can find all the links to the webinars on the link that's on the screen. So if you go to the Technorama website, you will be able to find it very easily. It's the one that says sign up here for all the future webinars. It's very obvious. So I highly recommend you sign up ahead of time. We have some excellent speakers. Next topic on the last Tuesday of March is From Studio to Speakers, the broadcast chain story. So I definitely recommend signing up for that. And we also have some useful links for you guys to check out. Of course, the Technorama website, the Facebook group, the Technorama Community Radio Q&A, and the CMTO Facebook page and CMTO website for extra training, not only in tech, but around other sector topics as well. If you could also fill out the feedback form for the webinar tonight, that would be extremely helpful. It's always good to know what you want to learn, what you're interested in, how you think we could improve, all of that, how great Josh looked today. Whatever you want to tell us, we want to hear it. It's, yeah, all happening. So thank you so much, everyone, for coming tonight, and thank you to our esteemed panel. And if that's everything, oh, John Maisels has arrived.
Got to leave pass.
No, game is still running.
John, do you have any parting words for everyone tonight? No, just thought you'd pop in.
Thanks to John for his pre-recorded first segment.
Yes, thank you also to John for the pre-recorded first segment. But thank you everyone for coming, and we will see you next month for From Studio to Speakers, the broadcast chain. And this webinar will be live as of tomorrow. But for now, see you later.
Good night. Yeah.
Good night. Bye.